Hello everybody, this is Jeff Janess. Welcome to our 6th lab exercise on raster analysis. Here we're going to try out one of our general raster tools that we discussed in lecture video 1, the Reclassify tool. We'll also see one way to clip a raster dataset to a polygon, and we're going to use the Extract by Mask tool for this. And we'll also use the Calculate Field tool to calculate proportion values to all rows in an attribute table. We're going to reclassify our aspect raster from lab exercise 1 into north, east, south, and west facing categories, plus flat areas. And then we're going to calculate the areas and percentages of each category in our management unit polygon. Now, in this demonstration, I'm going to be using ArcGIS Pro version 3.3.2, so if you're using a different version, then the tool windows might look a little different. Also, the tools we'll be using are available in a few extensions in ArcGIS Pro, and we're going to be using the Spatial Analyst ones, so first let's make sure the license is turned on. It's easy to do. Just come to the Project menu, come down to Licensing, click in here, scroll down to see Spatial Analyst. If it says yes, that means it's turned on and you're ready to go. If it doesn't say yes, then you'll have to hit Configure your licensing options to turn it on. All right. If you'd like to review more what you can do with the Reclassify tool, then take a look back at the first lecture video in this module. You can find it at this location here. Okay, first thing we want to do here is make a map that can contain our reclassification work. I've already created one here called Reclassification. If you don't have one yet, just hit the Insert and New Map and make yourself one. Like I said, I've already got one though. Okay, next we're going to add our data. We want to add our aspect data that we created in the first lab exercise in this module. If you can't find that, or if you don't have it, then go ahead and run through exercise 1 again and recreate it. It's pretty quick. So I have created it, and I'm going to add that in the Semester D unit. So we go to Catalog. The Semester D unit is in our Class Data folders. We go to Class GIS Data. It's in the Raster Functions folder. Here's Semester D unit. So I'm just going to right-click and add that to my map. And then we want to go to our database where we've been storing data for this module, and I have it in this database here. Here's my aspect I created earlier, so I'm going to right-click on that, add that to the reclassification map. Okay, and there we go. Our data is here and ready to work with. Now you might notice that ArcGIS Pro added this aspect data set as if it was already classified into different categories. This isn't actually that kind of data. This is a continuous data set of compass directions ranging between 0 and 360, plus -1 values for if it doesn't face any direction. And just to demonstrate that, I'm going to make a copy of this layer. If you select it, hold the Control key down and drag up, you get another. It's just a shortcut to copy the data. I'm going to re-symbolize this version of it to a stretch symbology, just to demonstrate that this truly is a continuous data set. It's not these categories. Now, if you have an older version of ArcGIS Pro, Aspect probably loaded up like this automatically. So they're changing the way layers load in newer versions of the software. Okay, let's open up the Reclassify tool and go to work with it. So it's in Tools. Just type in Reclassify. We're going to use the Spatial Analyst version. Okay, now here there's something that could be happening depending on the different versions of ArcGIS Pro you're using. And so I want to show this to you. We want a Reclassify tool that has 3 columns in this table. It has a start column, an end column, and a new column. If you load up a raster in here that is continuous like this first one, then this automatically gets shifted to just 2 columns. And like I said, we don't want that. If this is your situation, to get to the 3 columns, I have a little explanation of it here in the document. Go through these steps here. Basically, you'll just hit the Classify and just accept whatever shows up by default. It doesn't matter, we're going to clear it. By hitting that, we've changed this to 3 columns, so all is well. Then you just hit this little clear, remove all remap records button to clean it out. So now I have an empty table. This is where we want to be. Now, for those of you using newer versions of ArcGIS Pro in which aspect is pre-symbolized in this categorical format, if you drag this over here, then you automatically get the 3 columns. So this is where we want to be. We still want to clean it out. We want a fresh table. So hit this little button here to remove those records and clean it out. All right. So we should all be on the same page now, no matter which version of ArcGIS Pro you're working on. We want 3 columns and we want an empty table. So now we just start entering values into this table. The first row we're going to have for flat areas, the starting range will be -1. It'll go as far as 0, and we're going to call the new value of that a 0. Okay, we hit enter, we go to the next row. Now I have a table here that you can use to guide you. It's kind of small in the video, but it's big enough when we're in the actual lab exercise document. But I'll go ahead and type them in the way they should be. So the next row we're going to be a range from 0 to 45. We're going to call that a 1, and 1s are going to be our northerly directions. Hit enter. The range from 45 to 135 is going to have a new value of 2. That will be our easterly directions. A range from 135 to 225 will be a value of 3. These will be the southerly directions. And then we'll have 225 to 315. That'll be a value of 4, and that'll be our westerly directions. But we've still got to get the rest of the north, so the range from 315 to 360 degrees, that will also be a value of 1. So both this row and this row up here will represent north. All right, we hit enter, click off of it, it rearranges itself. All right, so this is the way we need the table to be filled out. So for all the original aspect values between these two ranges, we'll get a new raster. This new value here will be assigned to it. Okay, let's going to call this new raster directions. Okay. All right, that's all good to go. Just hit run. And now we have a new raster that just has values of 0s, 1s, 2s, 3s, and 4s. All right, so that's all we have to do to make the Reclassify tool run. Now, I'll tell you though, this Reclassify tool is temperamental. It's all the time jumping, adding new values when you click on something. It can be really frustrating. So if you just aren't able to get this thing to work, then you can also load a table with these ranges in it. So I've created a table for you if you need it. Just hit the Add Load Remap from Table button here. The table you're going to want to use is called Remap Table. It's located in the ClassGIS Data folder, in the Raster Functions folder, in a geodatabase called Contains Remap Table. So if you hit here, this is the raster functions, come to the Contains Remap Table geodatabase. This is the one. If you click that, hit OK, it'll just refill this for you in a way that is guaranteed to work. All right, so one way or the other, you'll be able to get this reclassified raster up here. Okay, let's move on to the next part of the project, and that is to clip this reclassified raster to the Semester D Management Unit polygon. We're going to use a tool called Extract by Mask. There's another tool that's specifically designed to clip rasters, but I'm most familiar with this Extract by Mask tool, so that's what I usually resort to. So that's what we're going to use here. We come to Tools, search for Extract by Mask. Here it is. The input raster will be the new directions categorical raster we just made. The clipping unit will be the Semester D unit right here. We're going to call our new raster dir extract. Okay, we're going to leave this analysis extent just the way it is by default. The default values are actually the rectangular extent that contains this input raster or feature mask data that you enter. So this is the rectangle that contains a Semester D unit, which is appropriate for this analysis. All right, so this is all set up, ready to go. We just hit run. Goes to work. And now we have a clipped raster, a clipped categorical raster that is just that portion that lays within our semester D management unit. All right, so we are well on our way. Now let's just make sure that we all have the same data going right now. If we open up the attribute table for this, we should see these values. So the value of 0, these are the flat areas. There should be 2,230 of them, and these rest of the values here. So these are the values that I am getting after I clip my categorical raster to the management unit. So if they're much larger than this, then there's a chance you are looking at the unclipped version. So just make sure you're on the right one. Now, it's also possible that you might have an aspect raster that's different than I am working with here. Maybe you calculate it with a different tool or with different settings, and so in that case the aspect values might be a little different, and in that case you'll just get a minor difference in the numbers here. So for those of you in my classes who are worried about your homework grades, I will be flexible with the grading. So as long as you haven't done anything obviously wrong, then I'm not going to mark you off on this. Okay, so question, what is the total number of raster cells in the polygon, which means the sum of all of these things? So for those of you who don't remember, we find out by just right-clicking on the field we're interested in, go to Visualize Statistics, opens a histogram that we don't care about, but it also opens up this table of statistics that we do care about. So if the question is, what is the total number of raster cells in the polygon? Well, that would be the sum. So the sum of all the count values, there's 2,230 cells with the value of 1, etc. You add all these up, there's 186,389. So that should be what you're getting. Now remember this number because you're going to have to use it shortly when we calculate proportions. So let's move on. Now let's add a new attribute field to our table. We're going to call it proportion. It's going to be a double precision field. So that is this button to add a field. This opens up the field map tool. So we're going to add a field called proportion. The data type will not be a long, but rather a double precision. Let's save our edits. Close this. And now we have a new field called proportion. Now we're going to fill this field with proportion values, and those proportions would be calculated as the number of cells in this category divided by the total number of cells. And so we just right-click on the field, go to Calculate Field. So here's where we put the formula. The proportion will be equal to the value in the count field here divided by the total number. So we get the count field here by just double-clicking on the field name. It fills it in with these exclamation marks. That's just because that's how Python refers to an attribute field. It encloses the field name within exclamation marks. So we're just going to take count divided by this number, 186,389, because that's the total number of cells. Now, just in case you're thinking about it, don't put in a number with a comma. The Python function that runs this tool won't understand that comma. It'll make it crash. So we take the comma out. The number is just these 6 digits. All right, hit OK. And these are the proportions of each category here. Now I have these values obscured just because this is actually part of the homework for my students at NAU. So I don't want to just give the homework answers here. I want you to actually do it. But yeah, how wrong can you go? You'll do fine with this. All right, and that wraps up the exercise. We have reclassified a raster dataset into 5 categories for 4 directions plus flat. Then we clipped that categorical raster to the semester D management unit. Then we calculated the proportion of the management unit that faces each of the 4 major directions and the proportion that is flat. And that's all there is to it. In our next lab exercise, we're going to try the zonal statistics tool that'll tell us the distribution of elevations and slopes and aspects and curvature values within our management unit polygon. So another really useful tool, and I hope to see you there. Thanks so much, everybody. Y'all take care. Bye-bye.